Hello sir, this is my task 2 presentation for Pure about geometric sequences. So we use this for faster calculations with sequence of numbers. We can also look for patterns and model real-life scenarios. We use the geometric sequences when we have a series of numbers that has a common ratio between the first and the next term. So for example, for this geometric sequence, there's a common ratio of r equals 2. So 2 times 2 is 4, and 4 times 2 is 8. And 8 times 2 is 16, and 16 times 2 is 32. The common ratio can be like in fractions or negatives. For example, it's these two, where this one is r equals a third, and for this one it will be r equals to negative 2. You find this by dividing the second number by the one before. So 1 over 6 divided by minus a third equals to minus a half, and that would be the common ratio. You could get some geometric sequences where they're unknown, so a would be the first term and r is the common ratio. The formula you might need to know is this formula, and this adds up all the terms from the first term a to the last term a plus r to the power of n minus 1. The second formula is this one, which adds up all the numbers in a convergent geometric series, and this means it can't be a 1 plus 2 plus 3, etc., because it adds up into an infinitely large number. It has to be something like a half plus a quarter plus an eighth, etc. Exam questions. So some exam questions could be this one, where it asks for you to show this, and what you do is you basically use the fact that AR divided by a, which is the first term, and this one is the second one, equals to ar to the power of 2, which is the third term, divided by ar. You basically sub in what you know, so the first term, second term, and third term, into this, and you can get the thing you have to show. For question B, you solve x using this formula, so you get x equals to 0 or 4. And then knowing that x is larger than 0, it cannot be 0, so it has to be 4. You sub in the x into the sequence you have, and it gives you 4, 8, and 16. From this, you know the first term is a, which is 4, and the common ratio is 2. And because a, r, and minus 1 is the formula to find the nth term, you sub the a, r, and n, you can find the value. For question C, you have to state whether this is in the value. So you put in the numbers, equals 4 times 2 to the n minus 1, and then you rearrange the equation to give you n as the subject, and you can find that it's 11. So for this question, you know the first term and the fourth term. Knowing this, you divide it for r equals 3. And to find the kth term, which exceeds 500,000, you set it as the a times r to the power of n minus 1 form. So that gives you this part. And rearranging it, you get 125,000. You then log both sides for k minus 1. And knowing this, you put in the calculator, and it gives you 11.68, and you round it up to 12. For this question, using the sum to infinity formula, you sub in the numbers you have and rearrange it for the show that question. For question B, you have to show the values of r. So you solve the question from you solve the equation from question A. For question C, you use the r values you have and sub it into the sum to infinity formula and rearrange it again for the new a values, 5 and 3. For question D, we have to find the smallest value of n, for which the sum from the first term to the nth term exceeds 7.99. As r has to be the smaller of its two possible options, it has to be 3 over 8 instead of the 5 over 8 here. We then sub in the numbers we have into the formula, this one, and then we rearrange it. So n is the subject, and it gives us 6.815. We then round it up for n equals to 7. For this question, we have to find the possible values of x, and because this series is convergent, we know that the second value, 3x, is less than 1. And because the values have to be positive, we use the modulus function to make it positive. We then rearrange this to make it so x is less than a third. For question B, we have to calculate the value of x. We do this with the sum to infinity formula here, and we just put in the numbers into the equation, which gives us x is equal to a sixth. A common mistake might be that they use the wrong formula. So for example, they might mix up this equation with this one. They might also not realize it's multiplication instead of addition, and might think it's an arithmetic question instead. They might not realize it's a geometric question as well, because it might be a sum, like sigma, but there's going to be actually like a ratio of r that they might not realize. Other links to areas of math would be the Archimedes theorem, where this parabola is fixed into like an infinite amount of triangles, so there's 1, 2, 3, 4, etc. until there's like infinitely small ones. Another one is fractals, where the shape itself repeats in very small ones, so like another one here, and it just repeats itself. Some real world examples could be for geometric equations would be like a word of mouth. So a customer might say that a restaurant is bad, and then that person would tell 4 more, and then those 4 more might tell another 4 more. Another real world example could be biology cell division. So cell could divide it from 1 to 2, which would divide into 4. It could also be physics related, so radial half-life of a material, which could be calculated with geometric sequences. That's the end of my presentation, sir. I hope it wasn't too boring. Thank you.